From space, the Earth's tallest structures create shadows that seems to stretch on forever. So for today's video, we're going to take a look at 20 of the biggest shadows on the Earth that are visible from space. Starting with number 20, the shadow of the Statue of Unity. The Statue of Unity is located in the state of Gujarat in India. It's the tallest statue in the world at 182 meters. Its height allows it to cast a long, sharply defined shadow that's clearly visible in satellite imagery. The statue stands on Sadhu Bet, a river island, and it rises above the nearby terrain, and as a result, during certain times of the day, especially early morning and late afternoon, it produces an elongated shadow that stretches across the water and landscaped areas. Satellite platforms like Sentinel-2 and Landsat-8 have captured the shadow under favorable lighting conditions. When the sun is low, the shadow will extend more than 600 meters. It appears as a narrow, tapering rectangle that mirrors the statue's vertical form. The length and direction will vary with season, and during winter, the sun remains lower in the sky throughout the day. The shadow becomes significantly longer. Cloudless days, of course, are especially favorable for capturing the effect, as the humidity and haze, which is common in these parts, can soften the shadow's edges. Because the statue stands on a river island with unobstructed surroundings, there's no tall structures nearby that might interfere with or distort the shadow. And that isolation means the shadow sometimes will stretch across the open water. From above, it stands out as one of the clearest man-made vertical shadows on Earth. That extreme height and placement beside this reflective water make it a prominent feature that satellites can capture repeatedly throughout the year. Number 19. The shadows of the Bungle Bungle Range domes. The Bungle Bungle Range is located in a national park in Western Australia, and it consists of hundreds of tall, beehive-shaped sandstone domes rising over 150 meters above the surrounding area. Because the domes are densely clustered, their shadows overlap and they create these complex patterns across the land, especially during the early morning and late afternoon when the sun is low. The Bungle Bungles are composed of these alternating bands of orange and dark gray sandstone. The color contrasts become even more striking when the shadows fall across the domes. Under the right lighting conditions, the shadow layers appear deep blue-gray, while the sunlit bands remain bright orange. During sunrise, the shadows stretch westward across the park's gorges and dry creek beds, and because the domes form tightly packed clusters, the shadows combine into these long, parallel shapes that trace the contours of the range. And during sunset, of course, the direction reverses and the shadows extend eastward across the plains. In the winter, when the sunlight arrives from a lower angle, the shadows become much longer and more dramatic, and sometimes extending far beyond the base of each dome. In the summer, though, the shadows, of course, are shorter and more concentrated around the domes due to the higher solar position. Instead of producing straight or triangular shadows, their curved surfaces generate these shadows with soft, flowing edges. The arcs are revealed in the dome's shape more clearly than in just sunlight alone, which highlights the circular cross-section. These shadows help outline fault lines too, erosion channels and sediment layers that do contribute to this region's unique appearance. And because the domes rise up sharply from the flat terrain, they provide strong markers for measuring any changes in solar illumination. From above, though, it looks like a vast mosaic of circular domes and elongated shadows, and it creates one of the most distinctive landscapes on the Australian continent. Number 18. The shadow of the Drakensberg Amphitheatre cliff wall. The Drakensberg Amphitheatre along the South Africa-Lesotho border forms one of the largest and most dramatic cliff faces. This huge basalt wall stretches about 5 kilometers in width, and it rises nearly 1,200 meters vertically from the valley floor. Because it is continuous, its shadow forms a wide, dark band across the grassy Royal Natal National Park below. In some satellite images taken by Sentinel-2 and Landsat-8, the shadow looks like a massive rectangular shape aligned perfectly with the cliff. The wall creates a clean, well-defined edge rather than a diffused shadow that's typical of gentler slopes. The effect is strongest during the winter, which is June to August in the southern hemisphere, when the low sun angles extend the shadow into the deep valley, and under those conditions it can stretch for more than 10 kilometers. During summer, when the sun rises a bit higher, the shadow does shorten, but it remains visible due to the extreme relief of the cliff. Occasionally, it casts its shadow onto cloud layers that drift through the valley below. When mid-level clouds move through the region at an altitude below the cliff summit, but above the valley, the walls project a large rectangular shadow across the cloud surface. Remote sensing researchers have used this shadow to study erosion rates along the basalt escarpment, and because the cliff face is so vertical, the shadow reveals fine detail in the contour of the walls, cracks, ledges, and protruding buttresses. These details can be difficult to distinguish under full midday sunlight. But from above, the amphitheater stands out as one of Africa's most impressive natural shadow formations. This is easily visible in satellite imagery. Number 17. The shadows of the long suspension bridges on the Yangtze River. The Yangtze River is home to several of the world's largest suspension bridges, many of which rank among the longest span structures ever built. Bridges like the Akashi Kaikyo, the Sutong Bridge, and the Yavuz Sultan create enormous shadows that are captured clearly in imagery, under the right lighting conditions, of course. Because these bridges rise high above the river, often more than 200 meters up from the deck to the tower top, their shadows project sharply across the water surface. Early in the morning or late in the afternoon when the sun is low, the sunlight reflects strongly off the river. Against this bright backdrop, the shadows of the bridge towers, the deck, and suspension cables appear dark and clean. The towers, of course, cast the longest shadows, often extending hundreds of meters across the water, and depending on the sun's direction, the shadows can sometimes reach the opposite bank. The suspension cables do produce a finer curved shadow that run diagonally across the river. In satellite image taken at higher resolution, like commercial imagery, the individual cable shadows can be seen forming sweeping arcs that mirror the bridge parabolic structure. During the winter, the sun's lower path causes the shadows to stretch farther downstream, sometimes creating elongated shapes. In the summer, the shadows are shorter, but remain distinct because of the reflective water. Fog and haze, which is common along the Yangtze, can occasionally soften the shadows, but on clear days following cold fronts, the effect is particularly strong. The high humidity can create a specular reflection off the water. From above, though, the shadows of the Yangtze River bridges do stand out as some of the most striking man-made shadow patterns in Asia. These are long, graceful silhouettes cast across miles of reflective water, revealing details of the design through light alone. Number 16. The shadow of the Great Mosque of Mecca. The Great Mosque of Mecca is the largest mosque in the world and Islam's holiest site. It casts a large and easily identifiable shadow. It's located in the center of Mecca. The mosque complex covers more than 400,000 square meters and includes multiple structures capable of producing long, sharp shadows. Most notably the Abraj al-Bait clock tower, which rises directly beside the mosque. The clock tower stands over 600 meters tall, and it makes it one of the tallest buildings on Earth, and as a result, it casts an enormous shadow across the Great Mosque and the surrounding city blocks. The projection often stretches across several prayer areas and adjacent roads. The length of the shadow can exceed 700 meters in winter when the sun's low enough, producing a dark, elongated shape that stands out clearly. In the evening, the shadow patterns shift dramatically. As the sun sets west of Mecca, the clock tower casts its shadow eastwards, sometimes reaching the densely built residential districts behind the mosque. Imagery from these moments shows the shadow cutting across buildings, roads, and even portions of the surrounding mountain faces. The outer walls, colonnades, and minarets, some exceeding 89 meters in height, create additional shadows on the polished white floors. When viewed from above during low-angle sunlight, these shadows appear as geometric networks of thin lines radiating across the mosque's central courtyard. During winter, when the sun travels lower across the sky, the shadows lengthen and become more prominent. Additionally, Mecca's typically clear desert atmosphere provides excellent conditions for this shadow visibility. There's little haze or fog to obscure the projection. From above, the shadow of the Great Mosque of Mecca, and especially the massive shadow of the clock tower, is one of the most impressive urban shadow features on Earth. Number 15. The shadow of the Matterhorn. The Matterhorn, it's one of the most iconic mountains in the Alps. It casts a sharply defined and highly recognizable shadow that's visible in high-altitude photography and in satellite imagery under the right lighting conditions. Rising to over 4,400 meters, the mountain stands alone as a sharply pointed pyramid, making itself unusually crisp compared to the broader, more diffuse shadows cast by ridges or massive-style peaks. When the sun is low, the shadow can stretch many kilometers across the surrounding glacier system, including parts of the Gorner Glacier, the Zmutt Valley, and other high alpine basins. In winter, when the solar angles are lower, the shadow reaches its maximum length and can be seen sharply cutting across the ice, rock, and even cloud layers. Imagery has captured the Matterhorn shadow most clearly during winter mornings when the illumination from the southeast contrasts with the mountain's sharp-angled faces. High-resolution instruments have documented the shadow showing a dark, elongated, triangular outline, and snow cover greatly enhances the visibility of the shadow as the bright reflective surface heightens the contrast. Unlike many alpine peaks that have jagged ridges or multiple summits competing for prominence, the Matterhorn summit is singular and sharply pointed, and that yields a shadow with a well-defined apex and a clean silhouette. When cloud layers sit below the summit, the peak will project a triangular shadow onto the cloud's surface, similar to the broken specter effect seen in other mountain regions. The phenomenon's well documented, and it's only sometimes captured in satellite imagery because it requires very specific atmospheric and lighting conditions. Sometimes summer haze and convective cloud growth will often obscure the peak, and while winter's clearer atmospheric conditions allow for more frequent and sharper shadow capture, remote sensing specialists sometimes use the mountain's shadow to verify snow brightness algorithms and terrain illumination models in mountainous areas. From above, it looks amazing. The Matterhorn shadow stands out due to its clarity. Among the alpine peaks, no other mountain produces a shadow as visually distinct and is immediately recognizable as the Matterhorn's. Number 14. The Shadow of Mount Fuji. Mount Fujisan, Mount Fuji, it casts one of the most geometrically distinctive shadows on the planet. Standing 3,776 meters tall, it's Japan's highest peak, and it stands alone in the landscape, giving it an unobstructed space to project a clearly defined shadow. From above, the shadow is most apparent during winter and early spring mornings when the sun is low in the southeastern sky. Under these conditions, the shadow will stretch northwest and measure more than 20 kilometers long, depending on the atmospheric clarity. The snowy terrain gives it strong contrast, and the isolated topography makes Fuji's shadow unusually clear in remote imagery compared to other mountains of similar height. Unlike many large mountains where the ridges and sub-peaks and irregular slopes will distort the shape of the projected shadow, Fuji's smooth profile creates a triangular outline that's both sharp and symmetrical. The shape's so consistent that it's often used in remote sensing to teach materials to demonstrate basic principles of topographic shadowing. Missions like Terra, Aqua, Landsat, and Sentinel have recorded instances of Fuji's shadow under suitable conditions, and these images will typically show the mountain as a bright white cone in winter, casting a dark fan-shaped shadow that extends across the surrounding forests. When cloud layers will drift in near the summit, Fuji will cast its shadow onto the cloud deck itself. This produces an effect in which the large triangular shadow is visible floating on top of the clouds. It's been seen for decades, and it's sometimes called the Fuji shadow on the clouds. It's also appeared in satellite imagery too when cloud layers align correctly. With no nearby peaks of comparable height, nothing will obstruct or distort this projection. The separation allows the shadow to spread cleanly across villages, roads, and forestry zones. And from a satellite perspective, it's one of the clearest examples of large-scale topographic shading on Earth. It's got symmetry, length, and consistency that makes it a standout case. Number 13. The Shadow of Mount Etna, Italy. Mount Etna is one of the most active volcanoes in the world, and it casts a remarkably large and sharply defined shadow that's frequently visible in imagery. Standing about 3,300 meters, with exact height changing slightly due to eruptions and summit activity, Etna dominates the eastern half of Sicily, and it stands high above the coastal plains that surround it. Its shadow is especially striking during sunrise, when the sun rises over the Ionian Sea, and at this moment the mountain casts a long triangular shadow westwards across the Sicilian landscape. In winter months, when the sun sits low on the horizon, this becomes exceptionally elongated and can stretch for about 30 kilometers. Snowfall on Etna's upper slopes will enhance it even further. The bright white snow surface shows the deep blue-gray triangular shape even more, which extends away from the summit cone. When the sun is lower over the Mediterranean, Etna will cast its shadow eastwards, and under completely clear conditions, the shadow can stretch directly across the sea. In some images, this dark wedge will appear as a tapering projection cutting across the ocean waves. During eruptions, even modest activity, the volcano will release columns of ash and gas that rise above the summit, and under low-angle sunlight, the peak itself can project a triangular shadow onto these plumes, creating a dark silhouette that's embedded within the rising column of ash. In these cases, the shadow will appear suspended in the atmosphere, following the shape of the cone rather than the terrain. The mountain rises from a landscape of rolling hills, canyons, and older volcanic deposits, and when sunlight grazes the landscapes at shallow angles, Etna's shadow can project across multiple ridgelines, leaving these alternating bands of light and shade. This creates a pattern visible from above where the shadow appears to step or walk across the terrain. These alternating bands will make the overall shadow look longer and more complex than the triangular projections cast by symmetrical cones. From above, though, the shadow of Mount Etna is one of Europe's most dramatic and instantly recognizable, whether cast across the Sicilian interior, projected into the Mediterranean, or suspended across an eruption plume. This one shows how a volcanic peak can generate large, well-defined patterns visible from hundreds of kilometers above the Earth. Number 12. The shadow of Mount Kilimanjaro. Mount Kilimanjaro, the tallest mountain in Africa, at 5,895 meters, casts one of the longest and most dramatic mountain shadows in the world. Kilimanjaro itself consists of 3 volcanic cones, Kibo, Mawenzi, and Shira, with Kibo being the highest and the primary source of the mountain's shadow. During sunrise, Kibo casts a long shadow westward, often extending tens of kilometers across the plains and foothills. When snow or ice is present on the summit, the contrast between the bright and reflective surfaces and the adjacent dark shadow becomes even more pronounced. In many of the satellite images, the shadow appears as a sharply defined wedge that stretches across the forested belts and dry savanna. This lack of competing high terrain ensures the shadow will remain continuous and easily distinguishable. In rare instances, the volcanic cone has projected a triangular shadow onto cloud layers lying below the summit. This produces a floating, dark shape on the cloud deck that mirrors the mountain's silhouette. And while visible mostly from aircraft or ground-based photography, this phenomenon has occasionally been captured in satellite images when clouds sit at the right altitude. The length of the shadow will vary substantially with the seasons. Around the equinoxes, when the sunrise and sunset angles will shift, the shadow shows its greatest variation. During the dry season, typically June through October, the air is clearer, making the shadow more prominent in imagery. During the wet season, cloud cover often prevents consistent shadow formation or obscures it from space. But because of its size and clean form, it's one of the easiest shadows to identify in satellite datasets that cover East Africa. From above, though, the shadow of Mount Kilimanjaro is a demonstration of how a lone, massive peak can imprint its shape on the surrounding land. This triangular projection sometimes extends across tens of kilometers, and it's one of the most dramatic mountain shadows anywhere on Earth. Number 11. The shadow of Denali. Denali is the highest peak in North America at 6,190 meters. It casts one of the most imposing mountain shadows on the Earth. Rising above the surrounding lowlands in just a few horizontal kilometers, it makes its shadow exceptionally long and clearly defined in imagery during early morning and late evening light. Its massive south face, one of the tallest continuous mountain walls in the world, does contribute to this shape and the intensity of the projected shadow. From above, it most often appears as an elongated wedge stretching across the glacier or the Ruth Amphitheater, depending on the sun's position. During winter and early spring, when the sun remains low on the horizon, the mountain will cast a shadow more than 30 kilometers long. It's easily detectable by Landsat or Sentinel-2 satellites. Snow cover surrounding the mountain enhances the shadow too. Illuminated snow produces a bright backdrop, while the shadowed regions appear sharply cut dark. Numerous scientific observations rely on the mountain's extreme height and the dramatic illumination contrast to study glacier features and atmospheric clarity. Its visibility from orbit is consistent, with shadows appearing under predictable seasonal and meteorological conditions. Compared to other major peaks in the contiguous U.S., Denali stands alone in terms of relief, meaning no nearby ridges interfere with or distort the shadow. On rare occasions, the summit will cast a shadow onto the clouds lying below the peak. When thin stratified clouds drift through the Alaska Range at mid-level altitudes, the peak will project a dark triangular imprint onto the cloud surface. Though more commonly documented in aerial photography, the effect is visible in some satellite images when the lighting is precise. But from above, it's one of the strongest examples of extreme 3D topography, generating long, dramatic shading across a snowy landscape. The clarity of it makes it one of the most easily identifiable shadows in North America's satellite imagery. Number 10. The shadow of Mount Rainier. Mount Rainier, at 4,392 meters, dominates the landscape of Washington state, and it produces one of the most dramatic mountain shadows in the U.S. This stratovolcano structure rises above the surrounding foothills and urban regions, which allows its shadow to extend far across the forests, glaciers, and in some cases, populated areas. Its position means there's no nearby peaks of comparable height to obstruct the shadow, and it makes it clearly detectable in satellite imagery. With morning shadows typically extending westwards across the river valley and beyond, during winter months when the sun angle is low, the shadow becomes sharply triangular. It's often visible from the Emmons Glacier or the Carbon Glacier, and towards the Puget Sound and entering the lowlands there. In ideal conditions, the shadow can stretch more than 20 kilometers depending on atmospheric clarity. Bright glacier surfaces reflect the sunlight strongly, making the shadow appear darker and more distinct. Satellites like Landsat 8 and Sentinel-2 and commercial platforms have captured multiple instances of Rainier shadow extending across glacier basins or diagonally across the forested slopes. Because it sits relatively close to populated areas, some images even capture the shadow reaching towards agricultural fields or residential zones during low-angle sunrise. Like other volcanic peaks, though, Rainier can project its shadow onto cloud decks under specific conditions. When mid-level clouds pass below the summit, the mountain will imprint a triangular shadow onto the cloud surface. And this has been photographed extensively from aircraft and occasionally appears in satellite imagery when the lighting and cloud altitude align. The Pacific Northwest, of course, is known for its heavy cloud cover during much of the year, which makes clear sky shadow sightings less frequent compared to other regions. However, during early winter mornings and late summer evenings, periods with better visibility, the shadow will appear with remarkable clarity. From above, though, the shadow of Mount Rainier is one of the most dramatic and visually striking shadows. It's long, crisp, and unmistakably tied to one of the continent's most prominent volcanic peaks. Number 9. The shadow of Mount Elbrus. Mount Elbrus, the highest mountain in Europe at 5,642 meters, casts a huge shadow across the Caucasus region. Because the mountain rises from the surrounding terrain and has two distinct summits, its shadow is both wide and easily identifiable in imagery. Elbrus sits slightly apart from the main ridge of the Greater Caucasus, which allows it to cast its shadow without any interference from nearby peaks. It's most pronounced during early morning hours when sunlight arrives from the southeast. And in winter, the shadow can stretch over 25 kilometers depending on cloud cover and solar angle. Those dual peaks, the west summit and east summit, also create a distinctive effect. When illumination is coming from the lower horizon, the two peaks sometimes cast partially overlapping shadows, producing a twin shadow or twin peak pattern that appears as two merging pyramids. The phenomenon is visible in specific high-resolution images taken during winter mornings. But satellites frequently capture its shadow during seasonal studies of the region's glacier health. Researchers use the mountain shadow to identify crevices and ice features that appear only when shade enhances the contrast of the surface. The shadow reveals subtle topographic details on the surrounding glaciers, and small depressions and ridges become more visible when the sun is low. Overall, though, the shadow of Mount Elbrus is one of the most recognizable shadows in the European region. Its length and clarity make it visible from above, and an important example of how large peaks will create these prominent shading areas across these amazing landscapes. Number 8. The shadow of the Andes above Aconcagua. Aconcagua is the highest mountain in the Americas at 6,961 meters. It casts one of the longest and most visually dramatic shadows anywhere. It's located in the southern Andes Mountains near the border of Argentina and Chile, and it rises thousands of meters above the surrounding valleys and glaciers. Aconcagua's shadow can stretch for amazing distances during sunrise and sunset, sometimes exceeding 40 kilometers in length depending on the season. The shadow becomes especially prominent in satellite imagery during winter in the southern hemisphere. At this time, the sun is lower in the sky throughout the day, increasing the shadow length and deepening the contrast. The shadow will typically project to the west in the morning and to the east in the evening, which forms a dark, tapered shape that cuts sharply across the terrain. Aconcagua's exceptional height allows it to dominate the surrounding shadow landscape, and even though it sits within a crowded mountain range, the shadow remains distinct because it rises more than 1,000 meters above the next tallest peaks in the region. Satellite imagery has captured its shadow in numerous passes. The images show a long, triangular projection extending across the snowfields. In some cases, the shadow will reach deep into Argentina's desert foothills, where the contrast between the shadow and the bright arid terrain is especially cool. Aconcagua also casts shadows onto atmospheric layers. With the thin clouds that drift at mid-level elevations below the summit, the peak will sometimes project a triangular shadow there. You can see this as well documented in aerial photographs, and it's appeared in select satellite images when the sun angles are low. The shadow's visibility provides some scientific help and information about solar angle, atmospheric scattering, and surface reflectance in the high-altitude environments here. Because Aconcagua is so tall and isolated in relative terms, its shadow is predictable and scientifically useful. From above, though, it ranks among the clearest mountain shadows in the Americas. Its ability to stretch across multiple terrain zones makes it one of the most dramatic natural shadows captured in satellite imagery anywhere in the world. Number 7. The shadow of Mount Shasta. Mount Shasta is a stratovolcano in Northern California, and it stands about 4,300 meters tall. It casts one of the most prominent and easily recognizable shadows in the western U.S. Its position within the Cascade Mountain range allows sunlight to strike the peak unobstructed, which produces a long, sharply defined shadow. It will cross over the lava plains and agricultural valleys, and this conical shape, similar to but steeper than many other Cascade volcanoes, creates an elongated triangular shadow visible from above during ideal sunrise and sunset conditions. Under those conditions, the shadow will extend more than 20 kilometers, reaching across the Shasta Valley and even touching foothill regions near the towns of Weed and Montague. In midwinter, when the solar elevation is low, the shadow extends farther than at any other time of the year, and it creates a long, dark wedge that contrasts with the snow-covered terrain. Occasionally, when the certain atmospheric conditions permit, Shasta will cast its shadow onto the overlying clouds, and when the clouds drift below the summit but above the lower slopes, the peak will project an inverted triangular shadow onto the cloud surface. The clarity of this phenomenon depends heavily on the cloud thickness, of course, and the angle of illumination, and the presence of moisture layers at the right altitude make it extremely visible. Its isolated topography means that nearby peaks don't interfere with it. This is in contrast to certain other Cascade volcanoes like Mount St. Helens or Mount Adams, which are partly surrounded by ridges that will distort their shadows. Shasta, by contrast, dominates the surroundings and therefore produces an uninterrupted projection. But from above, you can see it stands out as one of the cleanest triangular projections in the Cascade Range. Its length and sharpness make it an ideal example of a large volcanic shadow that's visible from above, showing how these isolated topography will interact with low-angle sun to create a dramatic large-scale shading pattern. Number 6. The shadow of the Grand Canyon Cliffs. The Grand Canyon. This is a weird one since it's not really a mountain, but it stretches for over 440 kilometers across northern Arizona and produces some of the most intricate and extensive shadow patterns visible from above. Unlike a single peak mountain that casts a unified triangular shadow, the Grand Canyon shadow system is a complex mosaic created by thousands of cliffs, mesas, buttes, and ridgelines. Its depth, averaging around 1,600 meters with a maximum depth exceeding 1,800 meters, allows shadows to fill the interior on a massive scale during early mornings and late afternoons. Now, these shadows within the Grand Canyon are most prominently visible in satellite imagery during winter, when the sun sits much lower in the sky, and under these conditions, the north-facing walls cast long, dark shadows across the canyon floor. This creates a dramatic contrast that outlines the canyon's full three-dimensional structure in high detail. One of the coolest shadow features, though, happens in the central Grand Canyon, near the confluence of the Colorado and Little Colorado River. Here, the cliffs exceeding 1,200 meters in height cast shadows that stretch across multiple river bends. Buttes like Vishnu Temple, Zoroaster Temple, and the Wotan's Throne produce distinctive solitary shadows that are also visible as isolated dark shapes on the canyon floor. When the sun is low enough, individual mesas will cast rectangular or trapezoidal shadows, while the narrow sides of the canyon become filled with darkness that show up as long, branching lines in imagery. During certain conditions, it can cast shadows onto the cloud layers that will drift below the rim. That phenomenon is rare. It's been documented and can appear in satellite images if the clouds lie at precisely the right altitude. But from above, you can see that Grand Canyon shadow are among the most detailed and distinctive shadow systems. Their depth and complexity create a shadow landscape unlike any other produced by a single mountain, making them one of the most visually dramatic shadow features visible from above. Number 5. Shadow of the volcano Mauna Kea. Mauna Kea, rising 4,200 meters above sea level and more than 10,000 meters above its base on the ocean floor, it's one of the tallest mountains on Earth when measured from its submarine base. During sunrise and sunset, the volcano produces a sharply defined triangular shadow that extends across sea and land, making it one of the most recognizable features in the tropical region. Its shadow is well documented during winter months when the sun's low angle elongates the projection dramatically. Under these conditions, it can stretch more than 30 kilometers across the neighboring terrain. You'll see satellite imagery from Landsat and Sentinel-2 often captures this phenomenon with the dark triangular shape clearly visible. The snow cover, too, on the surfaces here enhance the clarity of the shadow's boundaries. When the clouds settle at lower altitudes, too, along the slopes, the summit will cast this distinct triangular shadow onto the cloud deck itself. Although the mountain isn't perfectly symmetrical, numerous cinder cones do dot the summit plateau, the overall slope profile is smooth enough that the shadow retains a clear triangular outline. It widens towards the horizon and narrows towards the summit cone, which creates a geometric shape similar to shadows cast by other large, isolated volcanoes. From above, though, this shadow stands out. It's one of the most dramatic tropical shadows anywhere. The length of it and the interaction with the land and ocean surface makes it a cool example of how a single summit of a volcano can produce a shadow visible from hundreds of kilometers above the planet. Number 4. The Himalayan wall shadow over the Tibetan Plateau. Now, one of the largest continuous shadow systems visible from above isn't cast by a single mountain, but by the combined bulk of the Himalayan mountain range, where peaks exceeding 7,000 to 8,000 meters form a near unbroken wall between the Indian subcontinent and the Tibetan Plateau. During the winter mornings when sunlight arrives from the southeast at a low angle, this massive mountain wall casts a huge shadow that stretches across the southern margin of the Tibetan Plateau. Because the Himalayas have multiple peaks of extraordinary altitude, like Everest, Makalu, Cho Oyu, and others, the combined shadow they produce can extend over 100 kilometers. In certain images taken during early mornings from Tara or Modis passes, the entire boundary between Nepal and Tibet appears as a dark band where the Himalayas block sunlight from reaching the plateau surface. Each peak has its own long triangular projection, but the shadows overlap and merge, forming a continuous dark corridor stretching west to east across the plateau. And of course, the clarity of the shadow depends heavily on the season. During the winter, low sun angles will produce long shadows and high contrast, and during the summer, when the sun is higher and the monsoon cloud cover is frequent, the shadow becomes shorter. But the average elevation here of 4,500 meters does contribute to the strong shadow contrast because the plateau surface is often snow-covered or retains high reflectivity. When dust or thin clouds lie in the valley between the range and the plateau, the peaks will cast these visible triangular shadows onto the haze. This creates the appearance of these floating, dark, angled shapes hovering above the ground. From above, the Himalayan wall shadow, it's one of the largest and most visually powerful shadow features on the planet. It shows how a whole mountain range, not just a single peak, will block the sunlight across huge distances and produce a landscape-scale shadow visible for hundreds of kilometers above the Earth. Number 3. The shadow of Pico de Tede. Standing 3,700 meters on the island of Tenerife, Pico de Tede, it casts one of the most striking clean shadows in the world. Because Tede stands as a solitary peak in the Atlantic Ocean, with no surrounding mountains high enough to interfere with its projection, this volcano produces an unusually sharp shadow. What makes the Tede unique is the shape of its shadow. Although the volcano isn't a perfect cone, its flanks include lava flows, side vents, and irregular slopes. The shadow it casts appears as a perfect isosceles triangle. During sunrise, Tede's shadow can extend westward over the Atlantic Ocean for many kilometers, sometimes reaching neighboring islands like La Gomera under ideal atmospheric conditions. Satellite imagery frequently captures this phenomenon. In these images, the dark triangular shadow appears sharply defined against the lighter blue of the ocean surface. In many cases, Tede casts its triangular shadow onto the clouds itself, creating a floating triangular imprint that stands out clearly in imagery. This cloud shadow projection is one of Tede's most documented atmospheric phenomena. The island's trade wind inversion layer typically sits between 1,000 to 1,500 meters, which is well below the summit, and when the low clouds gather just below this layer, Tede rises above them like an island in a sea of clouds. At sunrise and sunset, the peak casts a long triangular shadow across this ocean of clouds, which is visible from above under the right viewing angles. In winter, when the sun rises at a lower angle, the shadow will stretch up to 40 kilometers or more across the ocean. In summer, the shadow is shorter but remains distinct because the mountain flanks fall steeply on all sides. From above, the shadow of Pico de Tede is one of the world's most recognizable. Its nearly perfect triangular form and its ability to stretch across kilometers, it makes it a standout example of a large-scale natural shadow that's visible from above. Number 2. The shadow of Uluru. Uluru, formerly known as Ayers Rock, rising just 350 meters above the surrounding desert, but stretching over 3.5 kilometers in length, casts a remarkably long shadow that's regularly visible in satellite imagery. Uluru's shadow does, of course, reflect the unusual shape, a huge elongated sandstone dome with deep vertical sides and a gently rounded crest. The result is a dark oblong shadow that sweeps across the desert floor at sunrise and sunset. Because Uluru sits nearly on perfectly level terrain with no surrounding topography to distort the shadow, the projection is exceptionally clear. In ideal conditions, typically early winter mornings, Uluru's shadow can extend more than 7 kilometers, which is a surprising distance for a landform of this small height. Satellite imagery and commercial high-resolution platforms frequently capture Uluru's shadow during low sun angles. The steep slopes cast sharp-edged boundaries that show up strongly against the bright red sands of the surrounding desert. This kind of tone contrast makes the shadow easy to identify even in lower-resolution imagery. The gullies, the fluted channels, and erosion grooves create this small-scale texture within the shadow, but the details generally smooth out in satellite imagery, leaving the overall silhouette clean and cohesive. Because Uluru is surrounded by culturally protected areas and national parks, remote sensing data is often used to monitor vegetation changes. Shadows cast by the monolith do help highlight subtle dune shapes, water tracks, and other landscape features normally that are washed out by strong desert sun. But from above, this one stands out as one of the most distinctive shadows in Australia. That elongated monolithic shape creates a large and easily identifiable dark projection that highlights one of the world's most famous landmarks. Number 1. The shadow of Mount Everest. Mount Everest, come on, it casts one of the largest and most recognizable shadows on Earth. It's a feature that's been repeatedly shown in high-altitude photography and satellite imagery, and even astronaut photographs from the International Space Station. Because Everest rises 8,848 meters above sea level, that's the tallest point on the planet by the way, its shadow stretches far across the land during early morning and late afternoon. It's pronounced in winter months too, when the sun sits lower on the horizon, which creates this long triangular projection that stands out against the snow. From above, it often appears as a dark elongated pyramid, extending westward or southwestward depending on the time of year and angle of sun. And while Everest itself is an irregular and complex structure, the shadow does just simplify into a geometric form because the sun's position is low enough to wash out smaller details. The shadow becomes most visible when the atmosphere is relatively clear and snow cover increases the contrast. In these images, darker regions can stretch well over 30 kilometers, and depending on the angle of the sun. But because the Himalayan plateau is already at a high elevation, the shadow really doesn't fall deep into valleys alone, but often slides across elevated ridges, which enhances the visibility of it. Pilots flying over the region have also reported seeing the shadow cast across the clouds when conditions do align. When low-level clouds will drift through the valley corridors, Everest Peak can project a visible triangular outline into the clouds. During the pre-monsoon season, when the skies are often clearer, the shadow tends to be sharply defined, and during the monsoon period, cloud cover often will obscure the mountain entirely. This seasonal variability is well known among imagery analysts who study illumination angles in this kind of mountain terrain. But remote sensing researchers sometimes use the shadow to validate sun angle models and atmospheric scattering calculation in the Himalayan dataset. But from an aerial view, few shadows on the planet are as instantly recognizable as the one cast by Mount Everest. Its outline and consistency across decades of imagery make it one of the most amazing examples of a natural shadow that's visible from space.